Okay guys, listen up. We're going to make this video on not all questions, but just some of them. As you can see, this is a review for the quiz that we're having tomorrow. It has both standard form and also vertex form. And some of them, you could look at it however you want. You could call this standard form or you could call this vertex form. If you want to look at it easier, it would be vertex form, which means you'd have to imagine some parentheses around the x, right? That way you could see that the h value, the number that's being added or subtracted in there, is what? 0. And the k value is 3. So if you imagine those parentheses there, you'll be able to see the vertex. If you look at it in vertex form, you'll be able to see the vertex 0, 3. That's the easiest way of doing it. Yeah, you could have looked at it in standard form, ax squared plus bx plus c, where the b is 0, and you use the formula, you plug in the b and the a value, but it's easier to think of the parentheses, see it in vertex form, and get that vertex. Let's graph that vertex, 0, 3. Next thing to do is draw your axis of symmetry, which is obviously the y-axis here. And let's also state that axis of symmetry equation. You always want to state it as x equals whatever that x value is, which is 0, the x value of your vertex. And we need either pattern or use an XY table, an input-output table. It's totally up to you guys. I would use a pattern, especially because you don't have to modify the pattern. It's -1. The a value is -1, which means you could absolutely use the pattern 1, 1, 2, 4, 3, 9. Now let me repeat this again, that these guys are not coordinates. It's not the coordinate 1, 1. It's not the coordinate 2, 4. These were coordinates from the parent graph. Right here, it's just a pattern from the vertex. A pattern from the vertex. Now we do know it's opening down because it's negative, so we're going to do 1, 1 first, 1 over, 1 down, and we're going to put a dot right there. We're going to go back to the vertex, and we're going to go 2, 4, 2 over, 1, 2, 3, 4 down, and put a dot right there. And then we're going to go 3 over, 1, 2, 3, 1, 2, and 9 down. I'm sorry, 3 over, 9 down from the vertex. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And all we have to do is map those points over to the other side of the axis of symmetry. Right here, right there, and right there. How do I do that so quickly? I already know it's at this level. I just count 1 unit away, 2 units away, 3 units away, and that's it. So we've graphed our parabola. All we need to do is connect the dots. And now let's state everything else that we can, because every detail will be graded on tomorrow's quiz. So the domain, you're going to say x equals all real numbers. Box that in. Range, you're going to say y is what? Greater than or equal to or less than or equal to? Less than or equal to the y value of the vertex, which is 3. Perfect. That's another point right there. The X-Intercept, where does this cross the x-axis? This is an approximation, guys. Here's 0, here's 1, here's 2. It doesn't get quite to 2. So you can say like 1.7, 1.8, right? And also -1, -2. It doesn't get quite to -2. So you can say -1.7, -1.8, whatever you want. So I would do this. Squiggly lines, that means it's an approximation. -1.8 and +1.8. So that's my answer for the x-intercepts. It's an approximation of where it crosses the x-axis. Most of the time it crosses at 2 locations, but sometimes it only touches it at 1 spot, and sometimes it doesn't even cross at all. How about that y-intercept? Where does it cross the y-axis? You could clearly see it's at 3. So just put 3 right there and you are done. Okay, so you get, it's not just about graphing. Some people are going to graph, they're not going to fill this in, you're going to flunk the quiz, right? You have to graph it, that's 2 points. You get another point for your vertex. You get another point for the axis of symmetry. You get another point for the pattern or the table. You could use the input-output table if you want. Plug in any numbers you want. If you're confused about that, just think about it. You could make an XY table and plug in the number 1 if you wanted to, and think about that. Plug in 1 right here. 1 squared is 1 with a minus in the front. That's going to be a -1 plus 3. That would be 2. So this is an actual coordinate 1, 2. So you could have done it this way, where you go 1 on the x, 2 on the y. There's your dot, 1, 2. The coordinate 1, 2. You could have plugged in 2 if you wanted, right? Plug in 2 into the XY table. Plug in 2. 2 squared is 4. Negative 4 plus 3, that's negative 1. So when you plug in a 2, you get out a negative 1. And if you go to that coordinate, 2, negative 1, you get to that point right there. So you could use an XY table if you want, or you could use a pattern if you want. Either way is perfectly fine. So that was an example of vertex form, I guess. Let's do one where it's just standard. Number 4 is just standard. Let's do that one. I cannot see the vertex, right? There is no h and k right here. So I have to use the formula x equals negative b over 2 times a. And in order for me to use this formula, it's a great idea to use parentheses, negative parentheses over 2 times parentheses. That way you could plug in your b value and your a value, and you don't even need the c value. The a value is 1 right here, which means that we could use the beautiful pattern 1, 1, 2, 4, 3, 9. So let's plug in the b value of negative 2 right in there, the a value of 1. The negative negative up on top becomes positive. We end up with positive 2 over positive 2, which equals 1. And that is the x value. To find the y value, we simply need to plug it back in. So we have y equals x squared minus 2 times x minus 3. Where am I getting that from? From the original equation. And of course I put parentheses in place of the x's. That way I could take the x value of 1 and put them right into those parentheses. So we have the x value of 1 going right in. Doing the math, you could do it all on a calculator, or you could carefully do it on paper here. 1 squared is 1. 2 times 1 is 2 with the minus sign in front. Bring down the minus 3. 1 take away 2 take away 3 is negative 4. So your y value is negative 4. Again, your x value was 1. Your y value was negative 4. That is an answer. That's a point. Let's graph that coordinate, positive 1, negative 4. It's right here, 1 on the x, negative 4 on the y. Step 2 is to draw your axis of symmetry right through that vertex. And that axis of symmetry equation is x equals positive 1. Now let's use a pattern or a table. I don't know, you guys want to use a pattern or a table? Pattern's definitely easier. You save a lot of time, and there's less likelihood of you making a mistake with the math. So the pattern is 1, 1, 2, 4, 3, 9. So from the vertex, I want to go 1 over and 1 up or 1 down. What do you guys say? Up. Because the a value is positive, we know it's going up. So we're going 1, 1, 1 over, 1 up. Let's put a dot right there. Go back to the vertex. And now we're going to be going 2 over, 4 up. 2 over, 1, 2, 3, 4 up. And we will be right at that location. And then go back to the origin, not to the origin, to the vertex, and go 3 over, 1, 2, 3, 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. You have your 3 dots. All you got to do is map them over to the other side. There it is, and there it is. Connect your dots. You have that perfect parabola opening up. Put some arrows on it. Let's answer the rest. We already have the axis of symmetry. Let's go for the domain. X equals all real numbers. Let's go for the range. Y is greater than or equal to or less than or equal to? Greater than or equal to, because it's opening up, and it's greater than or equal to the y value of your vertex, which is negative 4. The X-Intercept, where does it cross the x-axis, guys? Do I need to put that approximation? No, because it's precise. It crosses the x-axis at negative 1 and 3. It crosses exactly right here and right here. So these are exact locations, negative 1 and 3. And you get another point for answering that. And how about the Y-intercept? Where does it cross y-axis? You could visually see it at negative 3. And if you can't visually see it, make sure you just plug in 0 into your x's, and you should be able to get your c value, which is negative 3, your output, negative 3. Yep, it's pretty easy. Well, since we're doing the even ones, I guess let's just keep going with the even ones. We have another vertex form. This one should be a little faster because we don't have to use a vertex formula. What is a vertex? -4 and -1. Perfect. The h, you think opposite. That +4, you actually write it as a -4. The k value, the -1, you take it for what it is. You leave it -1. Okay. Let me graph that. -4, -1. It's right here. Let's draw our axis of symmetry right through it. And what's the equation of that axis of symmetry? X equals the x value of your vertex, -4. And then we need a pattern or an XY table. Okay, so you could make an XY table and start plugging in numbers that are close to your axis of symmetry, like -3 and -2. You could plug in -3 and -2. So like, check this out. Let me do a -3. I'm not going to do all of them. I'm just going to do an example of how you could plug in a number. -3, what's -3 plus 4? -3 plus 4 is 1. And 1 squared is 1. And then 1 times -2 is -2. And -2 minus 1 is -3. So when I plug in a -3, I get out a -3. So that is a coordinate. Let's go to the coordinate -3. Now notice, this is not a pattern. This is a table. So this is not from the vertex. This is from the actual origin. Where's the location -3, -3? It's right here. -1, 2, 3, -1, 2, 3. Put a dot right there. So you could plug in more numbers. Like you could plug in a -2. You could plug in a -1. So you could get more coordinates, right? And then once you get those coordinates, you could map them over to the other side. So I hope you guys understand how to use an XY table. But you could also use the pattern, but you have to modify it, right? Let me show you how to modify the pattern. 1, 1, 2, 4, 3, 9. Now, before, where does this pattern come from? From the A value of 1. But because the A value is 2, I'm not going to call it a -2. Negative just means that it's going to be opening down, and we already know that. But I need to modify this pattern because the A value is 2. The 2 is going to change the outputs of this pattern. So instead of 1, I will have 1 times 2. Instead of 4, I'll have 4 times 2. Instead of 9, I'll have 9 times 2. So my new modified pattern becomes 1, 2. 4 times 2 is 8. And 3, 9 times 2 is 18. So the blue numbers are the new pattern. 1 over 2 down, 2 over 8 down, 3 over 18 down. The original pattern was 1, 1, 2, 4, 3, 9, but we had to modify the 1, the 4, and the 9 by that new A value of 2. Multiplying all those outputs of the pattern, you get the new outputs of the pattern, 2, 8, 18. Now this is a pattern from the vertex. These are not coordinates. So if I did go 1 over 2 down from the vertex, check this out. Here's my vertex, 1 over 2 down, I'd get to that blue dot. So again, you could use an XY table to get to that blue dot, or you could use a modified pattern to get to that blue dot. You could use an XY table to get more points, or you could use the pattern from the vertex to get more points. I'm going to use a pattern, 2 over 8 down. So from the vertex, 2 over 1, 2, 3, 4, 5, 6, 7, 8. I'm 1 dot off. You know what? On tomorrow's quiz, if you're 1 dot off the graph, go ahead and plot that dot there, all right? I want to see it. Now, if you're 2, 3, 4 dots off, you don't have to worry about it. If it's 1 dot off, might as well put it on there. Let's map everything over to the other side. 1 dot here, 1 dot there. Connect your parabola. And we are done. The only other thing we need to do is state all the details, like the domain. Domain's a free point, guys. If you guys mess up on domain, seriously, you don't, that's just ridiculous. The domain is x equals all real numbers. That's the answer, right? To any parabola, when they ask you to the domain, x equals all real numbers. The range, it's going to be y, and so it's going to be above or below a certain value, the y value of your vertex. It is less than or equal to because it's opening down. The y value of your vertex is -1, right? Y value of your vertex, it's up here, -1. So y is less than or equal to -1. The X-Intercept, where does it cross the x-axis? It doesn't, so you just say none. There are no X-Intercepts. It does not cross. How about the Y-Intercept? Where does it cross the y-axis? Okay, now it looks like it doesn't, but we know that the parabola continues to go this way forever and go this way forever. That's why the domain is all real numbers, because even though it's opening down, it does go to the left forever and to the right forever. So at some point way down here, way down here somewhere, it's going to cross that y-axis. Does that make sense? All right, so we can't see it visually, which means we need to find it algebraically. How do we find a y-intercept? I hope you remember. You set x equal to 0. So this is what you need to know. I'm going to put a little cloud, like as in that's what you need to know in your head to be able to figure this one out. So let's actually do that. Let's rewrite our equation. Y equals -2 parenthesis x plus 4 squared minus 1. And we just said we're going to set x equal to 0. So let me erase the x and let me put a 0 right in there. And let me do the math now. Inside of the parentheses, 0 plus 4 is 4. And when I go 4 squared, I have to do exponents first. I get 16. So I really have a -2 times 16 minus 1. -2 times 16 is -32. And -32 minus 1 is -33. So the y-intercept value is at -33. So there's no way we could have seen that visually, because this graph, this parabola will not cross the y-axis till way down here at -33. Make sense? So we've done 3 questions. I mean, these are good examples. The test is going to be exactly like this. You have to answer every single thing like I did. And you know what? I'm going to ask you tomorrow to box everything in, whatever your answer is. So this is my answer on domain, box it in. This is my answer for range, box it in. This is my answer for X-Intercept. You have to box in everything. You're going to be getting 1 point for each of those, maybe 2 or 3 points for the graph itself. Okay, guys, final question that I'm going to do on this video, number 9. I want to go over this one because this one has a fraction for the a value. So beginning, our h value, our k value gives us our vertex. Think opposite on h, it's +1. The k value is +4. The vertex is 1, 1, 2, 3, 4 right here. Let's now draw our axis of symmetry right through it. All this is easy stuff. The axis of symmetry is the equation x equals the x value of your vertex, which is 1. Now let's use either a pattern or the XY table, the input-output table. Now let me kind of explain both again, just for fun. If you're going for an input-output table, you could plug in any number you want, kind of like, let's say you want to plug in 0 for x. If you plug in 0 for x, that'll be 0, take away 1, which is -1. -1 squared is +1. +1 times half is half. And then half plus 4 is 4.5. So when you plug in a 0, you get out of 4.5. So let's go to the coordinate 0. 1, 2, 3, 4.5 would be halfway there. Okay? So let's put that 0.5 right there. 4.5. So as you could see, you could plug in numbers and pull out answers, and those will be actual coordinates. I prefer to modify my pattern. So my pattern is usually 1, 1, 2, 4, 3, 9. Let me write that down. 1, 1, 2, 4, 3, 9. But our a value is now 1/2 instead of the regular 1 that we're used to that we could use this pattern on. So we need to modify the outputs of this pattern according to this new a value. So we're going to have to actually multiply by half, multiply by half, multiply by half to modify this pattern. So I'm really going to have the 1 and then half, because 1 times 1/2 is 1/2. And then I'm going to have 2, and then 4 times half. What's half of 4? That's 2. And then 3, and then 9 times half. What's half of 9? That's 4.5. So your new pattern is in red right here. 1 and then 1/2, 2 and then 2, and 3 and then 4.5. So from my vertex, I'm going to go 1 over and then halfway up. I'm going up because the a value is positive. Where is it at? Yeah. That's a positive 1/2 a value, so I'm going 1 over halfway up, and I put a dot right there. And then I go back to the vertex, and I'm going to go 2 over 2 up. So back to the vertex, 2 over 2 up, and put a dot right there. Then I'm going to go back to the vertex and go 3 over and 4.5 up. So 1, 2, 3, 1, 2, 3, 4, and then 0.5, it's really close. So like I said, if it's 1 unit off or half a unit off, let's actually plot that point. 4.5 is right here, from the vertex that is. Let's map everything over to the other side. That dot, you get that dot, and that dot right there. Connect your dots. You have that pretty wide parabola, because of course the a value is closer to 0. The closer it is to 0, the wider the parabola gets. Let's state everything else we need to state. The domain, x equals all real numbers. The range, y is what? Y is what? Greater than or equal to 4. How about the x-intercept value? None. It does not cross the x-axis. How about the y-intercept? Where does it cross the y-intercept? 1, 2, 3, 4.5, right? 4.5. We are done. 5.5? I don't know. Let me count again. So here we go. 1, 2, 3, 4, 4.5. Make sure you finish the rest. I'll be checking this tomorrow. And you have your quiz tomorrow.